Imagine a road traversing mountains where the air is so rarefied that each step seems heavier. Now, imagine that same road descending into humid valleys, crossing dry deserts, cutting through deep ravines, and climbing slopes where a modern road would probably require machines, explosives, steel, trucks, and weeks of calculation. Now remove all that. Without wheels as the main transport system, without horses, without iron, without modern concrete, without digital maps, without motors. And yet, the Incas built one of the greatest road networks of the ancient world. The most interesting question is not just, how did they do it? The most difficult question is, why did the system work so well precisely because they did not try to build the way we would build? That is the part that almost always goes unnoticed. When we think of advanced engineering, we imagine bigger machines, stronger tools, more complex materials, and speed. But the Inca road forces you to reverse that logic. It shows a civilization that looked at the terrain not as an enemy to be conquered, but as a force to be understood. The true secret was not in dominating the mountain with brutality. It was in negotiating with it. And that difference changes everything. Because perhaps the great lesson of the Incas is not that they were more advanced in the modern sense. Perhaps it is something more uncomfortable. They solved an impossible logistical problem without relying on what we consider indispensable. And, in some ways, perhaps that approach still has something to teach modern engineers. But to understand that, we need to abandon the simple image of an ancient road and look at the real problem. It was not just about building a path. It was about keeping an empire running on one of the most difficult terrains on Earth. And that is where the story begins to get much more interesting. At first glance, a road seems like an obvious thing, an open space where people pass, a line connecting one place to another. But that is just the appearance. A real road is a technical decision repeated thousands of times. Where does the path go up? Where does it go down? Where will water run when it rains? Where will the soil give way? Where does stone need to bear weight? Where will a bridge be safer than a detour? Where is a staircase better than a ramp? Where is it better to follow the mountain instead of trying to cut through it? That was the Inca problem. The empire needed to connect extremely different regions: cold highlands, agricultural valleys, coastal deserts, humid forests, and Andean slopes. UNESCO describes the Capac Ñan as a network that connected some of the most extreme geographies on the planet, from snow-capped Andean peaks to forests, fertile valleys, and deserts. That means the Incas were not building one road. They were building several different solutions disguised as a single network. In some stretches, the road needed to resist rain. In others, ice. In others, erosion. In others, heat. In others, the brutal elevation changes of the mountains. A single solution would have failed, and that is the first important point. Inca ingenuity was not in repeating a model, but in adapting the method. They did not have the luxury of imposing a standard road across all territory, so they did something smarter. They let the terrain determine the engineering. Today, when a modern highway cuts through a mountain, it often tries to overcome the landscape. It removes earth, cuts rock, alters drainage, stabilizes slopes, and forces a line as straight as possible. The Incas had another logic. They seemed to ask, what is the most stable path that the mountain already offers? That question changes the entire project, because when you do not have trucks, carts with wheels, iron and heavy machines, efficiency is not in moving more material. It is in avoiding moving unnecessary material. That may be the first great lesson. Limited technology can produce sophisticated engineering when it understands its own constraints. But there is still a larger question. Even if the route was intelligent, how did such a vast network manage to last? The answer begins in the physical evidence itself. The evidence is not hidden in a secret temple. It is in the ground. In preserved stretches of the Capac Ñan, the road appears as a practical, dry, resistant work without ornamental exaggeration. Sometimes it is paved with stones. Sometimes it is compacted. In mountain areas, staircases appear, retaining walls, drainage channels, and narrow passages adapted to the terrain. The network itself included planned paths, paved stretches when necessary, staircases to overcome elevation, bridges, retaining walls and drainage systems. That detail is essential. The Inca road was not a passive line. It was a system. When the terrain rose too steeply, the Incas did not insist on a long and unstable ramp. They could transform the climb into steps. When water threatened to destroy the path, the design needed to direct that water away. When a slope could give way, retaining walls emerged. When a gorge interrupted the path, bridges of plant fiber entered, especially in regions where stone engineering did not solve everything. That is, the road was less like a modern highway and more like a sequence of local responses. Each stretch responded to a question from the terrain, and that changes how we see the system. It was not just a road of 25,000 miles. It was intelligence distributed over thousands of kilometers. Instead of looking for a single miraculous technique, we need to observe the combination of small decisions: drainage, slope, stone, compaction, maintenance, bridges, stations, messengers, administration, and labor. That is where the road stops being just an ancient construction and becomes a kind of territorial machine. A machine without wheels. Without wheels, because the Andean terrain made the wheel far less useful for heavy transport in many areas. Without iron, because the solution did not depend on cutting the mountain with superior tools. Without horses, because the communication and transport system was designed for another type of circulation: people, llamas, messengers, and support points. And here appears a central idea. The Incas did not compensate for the lack of certain technologies by copying solutions from other civilizations. They created a system coherent with the world they lived in, but that is only half the answer. The common explanation usually stops here. The Incas were good engineers. They built excellent roads, and that allowed them to administer the empire. That is true, but it still does not explain the most important detail. The most accepted explanation is straightforward. The Inca road system served communication, commerce, military movement, imperial administration, and territorial integration. And that explanation makes sense. An empire only truly exists when it can move information, people, resources, and orders. Without communication, power stays trapped in the capital. Without reliable paths, a distant region becomes almost another world. The Kapaknan solved exactly that problem. It connected administrative centers, settlements, agricultural lands, sacred areas, storage depots, conquered regions, and strategic routes. It was not a network built merely for convenience. It was government infrastructure. An Inca road did not just say, "You can pass through here." It said, "This territory is connected to the center." That traditional reading is strong because it explains a lot. It explains why the system was so extensive. It explains why it needed maintenance. It explains why there were support points. It explains why messenger movement was so important. It explains why the Spanish were impressed with the scale of the network. It also explains why the road was not just an engineering work, but a political structure. Up to this point, there is no need for mystery. The Incas had organization. They had labor. They had knowledge of the terrain. They had earlier Andean tradition in paths and regional networks. They had an administration capable of mobilizing communities for public works. UNESCO observes that the network was built by the Incas over several centuries and partially based on pre-Inca infrastructure. That is important because it avoids a simplistic idea that everything emerged suddenly, as if a civilization had invented a continental network from nothing. It was not like that. There was accumulated knowledge, there were previous practices, there was adaptation, there was continuity. But even respecting the traditional explanation, one question remains open. If the goal was to connect the empire, why was the solution so durable on terrains where many modern works struggle to remain stable? The common explanation says what it was for. But the most interesting point is how the solution was designed to survive, and that is where the missing piece comes in. The missing piece is not a secret tool. It is a shift in mentality. When we look at ancient roads, we tend to ask, what materials did they use? What stones? What tools? What paving technique? Those questions are useful, but incomplete. Because a road fails not just because of material. It fails because water gets in where it should not, because the slope is wrong, because the soil moves, because maintenance is ignored, because the design does not respect the environment, because the path was designed for speed and not for stability. The most intriguing point of Inca engineering is that it seems to have treated the environment as part of the project. In the mountains, water is a constant threat. It enters cracks, carries sediment, displaces stones, freezes, expands, creates erosion, and destroys foundations. A poorly drained road can look perfect in the first year and start to disappear a few years later. That is why drainage is not a detail. It is survival. And many Inca stretches show exactly that concern. Elevated paths, channels, positioned stones, containments, and local solutions to prevent the road from becoming a river during rains. The road did not need to be beautiful. It needed to keep functioning. That is a point that the modern public may underestimate. We associate progress with speed and scale. But in the Andes, a road quick to build could be a road quick to destroy. The Inca solution seems less concerned with overcoming the landscape and more concerned with remaining within it. That is a profound difference. A modern road may depend on heavy maintenance, machines, asphalt, concrete, replaceable parts, and specialized technical teams. The Inca road needed to be repairable within the social and material logic of the civilization itself. That is, it was not just built to exist, it was built to be maintained. And that changes everything. Because perhaps the correct question is not, how did they build a road without modern technology? Perhaps the correct question is, how did they design a road that did not need our technology to keep functioning? That question leads to the invisible problem. The invisible problem of the Inca road was not stone. It was coordination. Building a path is already difficult, but maintaining a network with thousands of kilometers requires something more complex: social predictability. Someone needed to know where each stretch passed. Someone needed to organize labor. Someone needed to guarantee repairs. Someone needed to administer depots. Someone needed to control circulation. Someone needed to feed workers and travelers. Someone needed to send messages quickly. Someone needed to decide which routes were prioritized. The road was only the visible part of a much larger infrastructure. It is like looking at a bridge and forgetting that before it, there was calculation, logistics, transport, feeding, command, maintenance, and authority. The real mystery is not just in the path cutting through the mountain, it is in the invisible organization that made that path make sense. That same problem appears in other ancient constructions, not just the size of the stone, but everything that needed to happen before the stone arrived in the right place. Logistics is the hidden side of engineering. In the case of the Incas, the road network also connected a network of human communication. The chasqui, trained messengers, traveled stretches and relayed information in sequence. The system did not depend on a horse running long distances, but on a chain of runners adapted to the terrain. That is another important turn. For a modern mind, absence of a horse may seem like backwardness. But within that environment, with extreme altitudes and narrow paths, a network of runners and support points could be more coherent than trying to impose an inadequate system. The same goes for the wheel. The wheel is extraordinary on prepared, flat, stable terrains and with adequate vehicles. But on steep trails, staircases, ravines, narrow passages, and extreme altitude, it loses much of the advantage. So what appears to be a technological absence may be, in practice, a system choice. The Incas did not create roads for wagons. They created roads for the real way people. Llamas, cargo, messages, and authority moved in the Andes. The road was designed for the body, for the terrain, and for administration. And that is very different from imagining a civilization trying to build a modern highway without modern tools. They were not trying to build our road, they were building theirs. And perhaps that is why it worked. But there are different ways to interpret that efficiency. The conservative hypothesis is that the Incas combined accumulated practical knowledge, state organization, mobilized labor, adaptation to terrain, and constant maintenance. That explanation is solid. It does not require lost technology. It does not require external intervention. It does not require forced mystery. It does not require imagining impossible tools. It requires something perhaps more impressive, a social system capable of transforming local knowledge into imperial infrastructure. That hypothesis explains much of the Capac Ñan. But there is a more intriguing hypothesis without being fantastical. Perhaps the great superiority of the Inca system in certain contexts was not in the materials, but in the design principle. While modern engineering often begins by asking, how can we impose the most efficient route? Inca engineering seemed to ask, what route does the terrain allow to remain alive? That difference is small in the phrase, but gigantic in practice. A modern road can overcome distance. An Inca road needed to overcome time. Overcoming distance is arriving faster. Overcoming time is continuing to exist after rain, ice, erosion, earthquakes, partial abandonment, and constant use. And that may be the key. The Incas were not maximizing speed like we do. They were maximizing continuity. In an Andean empire, continuity was power. A message that arrived safely was worth more than a theoretically faster route that could disappear in a rainy season. A bridge of plant fiber rebuilt periodically could be smarter than a permanent structure poorly adapted to the place. A stone staircase could seem slow, but on a steep slope it was more stable than a poorly drained ramp. A narrow road could seem limited, but if it was sufficient for the real flow of people and animals, it saved effort and reduced environmental damage. That is the most interesting hypothesis of the video. Inca engineering was advanced not because it looked like ours, but because it was radically coherent with its constraints. And there is a detail that shows that forcefully. The detail that changes the reading is simple. Many parts of the road do not try to seem grandiose. They try to be adequate. That is an important contrast. When we think of impressive ancient works, we look for monumentality, giant blocks, enormous temples, perfect walls, impossible stones. But the Capac Ñan impresses differently. It does not depend solely on a single spectacular visual moment. It impresses through the repetition of correct decisions over an absurd scale. It is an engineering of continuity. A stone wall can draw attention in a photo. A staircase can seem beautiful in a documentary. A bridge over a gorge can seem cinematic. But the true achievement is in the fact that those solutions were not isolated. They were part of a network. The Inca Road was like a sentence written across the entire continent. Each stretch was a word, each bridge a comma, each staircase an adaptation, each support post a breathing point, each secondary route a connection of meaning. When viewed up close, the road is stone, earth, step, and drainage. When viewed from a distance, it is a technology of organization. And here is the practical lesson. In complex systems, the most powerful solution is not always the most visually advanced. Often, it is the one that reduces friction. The Incas reduced friction between the center and distant regions. They reduced friction between altitude and movement. They reduced friction between rain and road. They reduced friction between absence of wheel and need for circulation. They reduced friction between extreme terrain and imperial administration. That principle is still current. Modern cities face flooding because they ignore drainage. Modern roads crack because they underestimate water and soil. Expensive projects fail because they try to impose a single solution to different environments. Digital systems, companies, and governments also fail for the same reason. They create structures too complex, disconnected from real constraints. The Capac Ñan reminds us of something uncomfortable. An elegant solution is not one that seems powerful. It is one that keeps functioning when it meets reality. And that may be the reason why the Inca road still fascinates. It is not just proof of ancient capacity. It is a silent criticism of our obsession with brute force. So, how did the Incas build such a vast network of roads without wheels, without iron, and without modern tools? The answer is not in a single technique. It is in a combination. They understood the terrain. They adapted the path to the landscape. They used stone, earth, containment, drainage, and staircases as needed. They built bridges where stone did not solve the problem. They organized labor. They maintained routes. They created a communication system coherent with the human body, with llamas, with altitude, and with Andean geography. They transformed infrastructure into political power. The traditional explanation is correct in saying that the Chapacñán served the empire. But perhaps it does not say everything. Because the deepest part of the story is not just that the Incas built roads, it is that they built a logistical solution adjusted to their own limitations. They did not have useful wheels for that type of transport, so they did not design a network for wheels. They did not have iron, so they did not depend on cutting the world with iron. They did not have motors, so they designed a system based on human effort, rhythm, support points, and continuity. They did not have modern technology, so they did something that we sometimes forget. They respected the problem before trying to solve it. That is the central thesis. Inca engineering reveals that a limitation is not just a weakness. In some cases, it forces a civilization to create more elegant, more adapted, and more durable solutions. That does not mean the Incas were superior to moderns in everything. It means something more precise. Facing the Andean terrain, they developed a profoundly intelligent response. And perhaps that is what still impresses us, not because the road is inexplicable, but because it is explicable in a way that forces us to rethink what we call progress. Sometimes, advanced is not having more tools. Sometimes, advanced is understanding constraints better, and few ancient works demonstrate that as forcefully as the Chapacñán. But there is a question that this video only opened. If the Incas managed to connect mountains, deserts, valleys, and distant regions with a network of roads, how did they make information circulate through that system? Because building a road is one thing. Using it as a living communication network is another. Without alphabetic writing as we know it, without mail horse, without telegraph, without modern maps, without paper circulating as a common document, still, messages, orders, news, and administrative information could move long distances, and that may be even more intriguing than the road itself, because the road was the body of the empire. But communication was the nervous system. In the next video, the question will be different. How did the Incas manage to communicate over thousands of miles without traditional writing, without horses, and without modern technology? And perhaps the answer reveals that the true power of the empire was not just in the stones of the path, but in the invisible speed of the messages that ran across them.